This planet Earth has rocks under the surface. If you dig deep enough, there are rocks. There are carbonate rocks, crystalline rocks, phosphate rocks, and sedimentary rocks. That takes in most of the rock varieties that we live on top of. One category, the phosphate rocks, often have uranium. That's because uranium combines with phosphates. So that's why you would find uranium phosphate together in some kind of a compound underneath the surface of the Earth. Sometimes it sticks right out, but mostly there's a little bit of covering soil. Uranium is radioactive with a long, long half-life, millions of years, so it's not going to go away. We have to adapt to it. Can you see those little dots and star-like things that are drawn coming up from the Earth in heat waves or little streams coming up in the air on dust particles? Those star-like things are the radioactive elements, and those littler dots are the lanthanide elements. They both come from the uranium phosphate rocks down below. Now, how do I know what's on those little dots and the dust particles? You take a paper towel, like a kitchen paper towel, and you hang it, you dampen it with a little water, the tap or any kind, and you hang it with a clothespin from someplace in your house, the kitchen, the bedroom, anywhere. And in the morning, you stuff it in a plastic bag, little plastic baggie, and you use the oscillator I was talking about to find out what's on the dust particle. That's how this information was obtained. And I don't know any other scientific experiments done yet to analyze the dust that's coming up from below the ground. But this is what I'm finding. A shocking assortment. Now, we always knew there was some radon coming up here and there. Take a look at radon, the radon page just before that. Radon has been studied quite a bit for 50 years already. So anytime you have a radioactive particle, it doesn't just act by itself. It breaks up, and that's what radioactive means. It's going to break up and make two other things. It's going to break, and then it's going to still leave a radioactive element behind. So as it breaks up, it releases some energy, and the energy can be either alpha energy or beta energy or gamma energy. It's called alpha radiation or beta radiation or gamma radiation, plus the leftover radioactive element. And if you start out, look for radon on the page called the radon chain. That's Rn. You see it originates from uranium-238. There's more than one kind of uranium because it breaks up and still remains uranium sometimes. But let's just quickly run down that list. Uranium-238, which is going to be in those rocks that we were looking at, it breaks up and it releases alpha radiation. You see that? Half of it has a terribly long half-life. That's from the beginning of the whole universe right there. And when it breaks up, what's left over is thorium, thorium-234, also radioactive. can you imagine trying to put a radioactive item like thorium into public commerce? But it was done. It was done 50 to 100 years ago when we made gas mantles out of them. Unbelievable. Then thorium itself breaks up again, and this time it releases a beta radiation and turns into proactinium. Then proactinium releases a beta radiation and becomes uranium again, a different weight uranium. And then that uranium goes to another thorium. That thorium goes to radium this time. And radium goes to radon. So that's how the radon gets made, that comes up from the ground and sails up into your kitchen air or wherever it can, just as though it were some kind of a fume, let's say tobacco fume. If you can smell tobacco or bacon frying, you know that it'll get through any little crevice, and we have to protect ourselves from that. But radon isn't the only thing. Radon breaks off an alpha radiation and then turns into polonium. Polonium is extraordinarily cancer-causing. Polonium-218 releases an alpha particle and turns into radioactive lead. See, whatever it turns into is radioactive, so that when you breathe in some radon, which turns into polonium, and it's in you, in your lungs, in your veins and arteries, it's turning into radioactive lead, and you know lead likes to go to bones. So any one of us would be expected to have quite a bit of radioactive lead in your bones. And there's a big difference. Radioactive lead is much more harmful than plain lead, because it is making mutations at the same time as causing the lead toxicity. The lead makes a beta radiation, turns into radioactive bismuth, which is also very harmful, radioactive bismuth. The bismuth turns into another polonium. That polonium turns into another radioactive lead. That radioactive lead turns into another radioactive bismuth, and this radioactive bismuth turns into another polonium. There are 3 poloniums here. Now, that has already been studied a lot, and mostly all these derivatives have not been studied, only the radon and major derivatives. It's really, I would say, just in its infancy. But what I did is I looked for all of these on the dust coming up into the house, and it was all there. And then if you look in your tissues, you'll see all these different things in different places, and that's how it got there. But what was not known is that you also have all these lanthanides there. Very often, a lanthanide breaks up the same way, because it's radioactive, breaks up the same way as radon does. And so we're living in a world of radioactive elements that we never knew before. Look at the table called the periodic table of elements. On the left side, you see the elements called Na for sodium, K for potassium, hydrogen, lithium. These are the most reactive elements that we have on this earth. They are so reactive that you can't hold them out in the air. They just light up and burn. And that's why you have something called a flare, for instance, a magnesium flare or something. You don't dare just have it open in the air. That's how reactive they are. The next group beside it has magnesium and calcium and strontium and barium. You see that? That's group 2. From the left, the second group over. They are very reactive too, not quite as reactive as the first group. And then the third group over is still quite reactive. And it has La down in the third group, the third one down. Can you spot La? That's lanthanum. Lanthanum is the first member of a whole group called the lanthanides, and they all belong in that square. Now, you can't, the only way they could shove it all in there was by making that line called lanthanides down below. Do you see that line called lanthanides? They all belong in that square called lanthanum. And they all have properties similar to the other ones there beside barium and strontium and calcium and magnesium. In other words, they behave like a metal, and they're going to combine with something at the other end of the table. Let's take a look at the other end of the table, which is over to the right, where you see, let's take a look here at the group that starts with F on top for fluorine. And underneath F is Cl for chlorine. You know how very reactive chlorine is. It wants to react with something on the left side of the chemical table. It wants to react with the sodium, magnesium, and lanthanum, the ones on the left side. Things on the right side want to react with things on the left side. So looking down at the groups, at the group at the right, you see fluorine, chlorine, bromine, iodine, and then the third one over, oxygen on top. You know that's very reactive. Oxygen is very reactive. You just do nothing, and it will change your iron to iron oxide, to rust. It's very reactive. Under oxygen comes sulfur, then selenium, tellurium, and then polonium. And polonium is what we have been finding as part of the radon series. So up from the Earth is coming a lot of polonium. And it's going to want to react with something on the left side, in other words, the lanthanides. And what I found is that coming up into my kitchen and other people's kitchens and bedrooms is something called polonium-cerium complex. There's polonium coming up, a terrible carcinogen. And there's not just radon, there's polonium. Polonium was already found to be the cause of lung cancer and the possible item causing cancer in cigarettes, for instance.